Hello students, hello guys. This is senior college mathematics and topic is approximation. If you are in SS1 to SS3, you are preparing for WAEC, NECO, GC, NAPTEP, JAM or any other external examination to get into higher school, this topic, this video, this lesson is for you. Watch it and learn one or two things from it. All right, lesson 3, approximation 3. So this is continuation of lesson 1 and 2 okay. In this lesson I want to talk about percentage error. Now, every measurement, no matter how carefully carried out, is an approximate. It's an approximate, no matter how careful. That measurement is an approximate. If different students are given the task to measure the length of the table in their classroom, for instance, as accurate they may be, some variations in the measurement will be seen. Yes, if different students are asked to measure the length of the same table in their classroom, as accurate each one may be, you will see some variations in the measurement. Yes, the different results depend on the characteristics of measuring instruments as well as the characteristics of the students carrying out the measurement. Maybe due to distraction from fellow students, maybe the measuring tape or ruler is not straight enough, so you see variations in the measurement. All right, if the height of a student is 1.2 meter, for instance, then the true or actual height could be between 1.15 meters and 1.2 meters. That is minus 0.05 meters or plus 0.05 meters. Now, the plus minus 0.05 meter is called maximum absolute error. Maximum absolute error. Now, the maximum absolute error is an allowance within which the actual measurement falls. It is called the precision of the instrument and the degree of accuracy. What that means is that in every measurement we try to give an allowance, we try to give room for error. Now, if the height of the student is 1.2, so because of the measuring instrument, we have it that it could be between 1.5 meters, that is 0.05 meters less, or 1.25 meters, that is 0.05 more. So we give that allowance for error, for possible error that may be encountered. So that allowance given is the maximum absolute error, that is called the precision of the instrument and the degree of accuracy. We always give that, and that forms the basis of percentage error. Okay, relative error. Relative error helps to precisely and satisfactorily judge the degree of accuracy of any measurement. Relative error is the ratio of maximum error or precision to the true measurement. Relative error is the ratio of the maximum absolute error, that is called precision, to the true measurement value. So this is how we express relative error. You know, you can express ratio as fraction. So you have maximum absolute error over actual value, and it's the same thing as precision all over measurement. Okay, if the relative error is expressed as a percentage, it gives a better picture of the precision of the measurement. So the percentage relative error is the ratio of error to actual measurement multiplied by 100. So relative error gives us a better precision about the measurement. So percentage error, denoted as PE, is equal to error over measurement times 100%. Simply put, error over exact times 100%. So this helps us to calculate the percentage error of any measurement, or estimate, as the case may be. Okay, examples. All right, before that, for updates, follow Voice of Peter Course via YouTube at Peter Course Educom. To do that, subscribe to this channel. Facebook, fb.me/petercourseeducom, Instagram at petercourseec, Telegram t.me/petercourseeducom. In all of these platforms, you get update from time to time about what is happening at Peter Course Education community, when the next teaching is available, and other information. Okay, let's go into example. Example number 7. A boy estimated his transport fare for a journey as 190 naira instead of 200 naira. So from here, the exact amount is 200 naira. So he estimated maybe 150, 190 can take him to that place. So there's already variation. Find the percentage error in his estimate. From the formula given above, percentage error is equal to error all over exact times 100. So what is the error in the estimate? That error is 10 naira. The difference between the exact estimate and the wrong estimate, that gives error. So you have 200 naira minus 190 all over 200 times 100. Okay, if you subtract, you have 10 over 200 times 100. If these two zeros, remove these two zeros, you are left with 10 over 2, and that is 5%. So the percentage error of the student estimate, or the boy estimate, is 5%. It's 5%. Okay, example 8. Calculate correct to two significant figures the percentage error in approximating 0.3752 to 0.4. So from here, the exact number that we have is 0.375, and this value is approximated to 1 dp, that is 0.4. Then find the percentage error of the estimate. All right, percentage error, as stated, is error over exact times 1000. So the error in this estimate is 0.4 minus 0.375 over 0.375 times 100. okay, times 100. If you do the subtraction, you have this, you have this. All right, so this place we are trying to apply the lesson from fraction, whereby we try to convert the denominator to a whole number. And if you do that, denominator is 3 decimal places. Luckily for us, the same 3 decimal place we have in numerator, so you have to multiply both numerator and denominator by 1000 in order to convert them to whole number. That's the step you have here. So if you multiply 0.025 by 1000, you have 25. And if you multiply 0.375 by 1000, you have 375, then times 100. If you reduce, you have 1 over 15 multiplied by 100, that is 6.7%. So the percentage error in approximating 0.735 to 0.4 is simply 6.7% from the computation. All right, okay, next example, example 9. A boy measured the length and breadth of a rectangular line as 59.6 cm and 40.3 cm respectively, instead of 60 centimeters and 40 centimeters. Full stop. What is the percentage error? What is the percentage error in his calculation of the perimeter of the line? Okay, now it is very clear. Instead of 60 against 40, he measured 59.6 against 40.3. There's already variation. All right, so to get the exact, we need the perimeter of the actual line and the wrong perimeter as well, because you know the exact is different between the actual and the error. All right, the given measurements are not to be used the way they are given, but you are expected to find the perimeter first, because you get the perimeter. All right, we also find the percentage error in the perimeter, so you must get the perimeter of that rectangular line. Okay, so for a rectangle, the perimeter is 2 bracket open length plus breadth. All right, the actual perimeter, the dimension for it are 60 against 40. So actual perimeter of line is 2 bracket open 40 plus 60, that is 2 into 100, and that is 200. Then we get the wrong perimeter using the wrong values of 59.6 centimeters against 40.3. So the wrong perimeter of line is equal to 2 bracket open 59.6 plus 40.3. When added, you have 2 into 99.9. When multiplied, you have 199.8. So percentage error is the difference in the actual and error over actual times 100. That is 200 minus 199.8 over 200 times 100. When subtracted, you have 0.2 over 200 times 100. If these 2 zeros take care of this 2 zero, are left with 0.2 over 2, and that is 0.1% as the percentage error in the calculation of the perimeter of the rectangular line. Okay. Next example, example 10. Adamu estimated the length of a room as 20 meters. He overestimated by 25%. What is the true length? In this case, you don't know the true length, but he overestimated the true length by 25%. So the estimated length is 20. You know the whole length, the whole estimation is 100%. So if he overestimated by 25, that means everything become 125%. So 125% of the true length, that is S, is equal to the length of the room as estimated to be 20 meters. That is what you have here. So you convert 125 to ordinary fraction. To do that, you divide it by 100. Of is times there, times S equal to 20. If you cross multiply, 100 will multiply 20, then you have 125 times S is equal to 100 times 20. To get S, the true length, divide both sides by 125. That is this step. By the time you reduce, you are left with 4 times 20 all over 5. If you reduce again, you have 4 times 4 over 1, and when you multiply, you have 16 meters. 16 meters. See that? So the true length is 16 meters. See that? From that 29, if you remove 25%, that overestimation, so that overestimation is about 4 meters. From 20, you have 16. You have 16. Okay. Example 11. Example 11. A wall is measured as 5 meters to the nearest meter. Find the actual length and the percentage error. Remember at the beginning where we said that an allowance is allowed. Now that the measurement is 5 meters, for calculate the percentage error, we need the error itself. So the error itself is the allowance we allow. 0.05 from 5, 0.05 to 5. So the actual length is between 4.95 meters and 5.05 meters. The error subtracted from 5, you have 4.95. The error added, you have 5.05. Thus, the maximum absolute error is 0.05. First, we get the relative error. Relative error is the maximum absolute error divided by actual measurement. That is 0.05 divided by 5, you get 0.1. Then percentage error. Percentage error is relative error times 100 from the beginning. Relative error is 0.05 over 5 times 100. When you multiply and divide, you have 1% as the percentage error in taking that measurement. All right. Example 12. If the percentage error of measurement is one whole number, 1/3%, and the actual measurement of the length of a tool is 12 centimeters, find the range of its value. The range of its value is simply converting the percentage error from percentage, then multiply it by the length of the 2, you get the value to be added, because the range now is that estimate plus the length of the 2. So first we take the percentage error, one whole number 1/3, convert it to improper fraction, you have 4/3. To convert it from percentage, you divide it by 100. From what you learned in fraction, division sign changes to times. The fraction 100/1 is inverted to 1/100. To get the range, that value to be added or subtracted, you multiply everything by 12. And when you multiply and divide, you have 0.16. So the range of value is the length of the 2 plus minus 0.16. So the range is between 12.16 or 11.84. Alright, since the actual length is given, our interest must be the other length, which should be 11.84, approximately 11.8 centimeter. So it is also possible to find the range of value when the percentage error and the actual measurement is given to you. So you convert the percentage error to ordinary fraction, then multiply by the actual measurement to get the value, because for you to have a range, you must add or subtract a value that is computed with that step. Then when you add and subtract, you have this range, So since the actual value is 12 given to us, we must be going downward to have the other length, which is 11.8 approximately. Okay, so this is how we calculate percentage error, relative error in approximation. All right, end of lesson 3. And the voice of Peter Cost, he says, thank you for taking your time to learn and follow this lesson to the end. He's wishing you unlimited success in all your endeavors and pursuit in life and career. Don't forget, watch out for more from the voice of Peter Cost. All right, for any question, any challenge, inquiry, you can contact the voice of Peter Cost via WhatsApp or send him a mail. For the complete package of this topic, approximation lesson 1 to 3 for offline usage, you can also contact him at a very little token. The complete package will be delivered to you. All right, if you are not safe, your life will be in crisis for sure. To avoid that, you need to be safe, and to do that, you give your life to the Lord Jesus Christ. He is the only one that has the power to save anybody. If you are saved already, I tell you, big congratulations. Live righteously and be prepared. Stay out of trouble. Take care of yourself. Stay well. Study your books. Do the needful at all time. And goodbye for now.